So, hi guys, thanks for being here. So, maybe let's start with a bit of an introduction first. So, who am I? I am Nitanshu. I'm currently building Banana SDK and joined Banana SDK as a founding engineer back then in January 2022, this year itself, uh, January 2023, this year itself, when we started Banana SDK after EAT India 2022 hackathon. I previously worked with MathWorks. Last 6 months I was working with MathWorks only and Banana HQ side by side, but then left MathWorks and got into Banana SDK for full time. And I previously worked with Zust Network as well. Zust Network is nothing but a privacy focused data sharing network. And yeah, recently we won the eGlobal Paris as a finalist winner as well. So and I was also fellow at Polygon Fellowship class of 2022 and Ethereum Inter Fellow. That's a bit of an introduction. Now let's jump into the actual thing. So yeah, what's we're gonna cover today? So we will first cover a few wallets and comparison what type of wallets exist in this ecosystem: smart contract wallets, wallets, EOA accounts, and we'll go a brief into 437 as Banana SDK purely relies on 437, so we don't want to miss that. And we'll talk on Banana SDK, Banana passkey-based mechanism for transaction creation and wallet creation, transaction signing and wallet creation. And we'll have a look on how you can integrate Banana SDK in your app, how much easy it is to integrate Banana SDK, and what's next. What's the plan of Banana to go after solving the onboarding issue? Yeah, so let's move forward then. So yeah, what are wallets? I guess like all of the people who are available, who are present here, for sure would be knowing what are wallets. And any beginner like who is just getting into this domain have to get into this steep learning curve of knowing what are wallets. Wallets are the first entity user need to get aware of when he enters into the Web3 ecosystem, because wallets are the gateway to Web3. They are an interface which allows you to interact with blockchain. If you want to interact with a smart contract, you need to connect a wallet to that particular protocol and then signs a transaction, and then it makes your transaction happen. Wallets holds your custody because it enables you to manage public private key pairs. If you are using MetaMask account, if you are using MetaMask, it has multiple public private key pairs. Those public private key pairs are your accounts, and those accounts are holding the custody, the funds which you will be having. And the custody of those funds sits with the wallet, sits with the public private key pair which has been generated via the seed phrase of MetaMask. So let's move forward. So yeah, let's talk a bit on types of wallet, and then we'll go a little deeper into smart contract account, what features we are getting with smart contract accounts, and a lot more. So types of wallet, one is EOA, which is just a public private key pair. You just get a seed phrase, start generating public private key pairs with that, and those public private key pairs are account. Public key is your Ethereum address. Private keys is another 32-bit string which enables you to kind of sign the data, and that signature you can get it verify on chain, and that particular signature follows the K1 mechanism. And we have already K1 based precompile available on chain, which helps you to kind of verify the authority over that particular transaction. So you can use EOA for sending money, receiving money, and interacting with blockchain. And yeah, EOS are no-code accounts. Those are just merely a public-private key pair which just help you to send, receive, and interact. Now coming to smart contract accounts. Smart contract accounts are wallet with code, wallets with added functionality, not just your merely public-private key pair. If you lost your private key, you lost your fund, you lost the custody. So if someone else is having your private key, so those funds are no more of yours, it's of them because they hold your private key. You can do the existing stuff, which you can do with EOA. You can send, you can receive, you can interact. You can implement your own custom verification logic. Smart contracts, you all know, can be modifiable. And any kind of execution which is happening through smart contract wallet can be modified. The verification logic in that particular smart contract wallet, you can implement it at our own. In context of Banana, as we are allowing users to utilize their passkeys to sign their transaction. So for that thing, we had kind of like modified the validation mechanism, the signature validation mechanism, and we are using the R1-based signature verification mechanism. We'll talk about it a little bit in later. Modularity. Modularity is a concept which is evolving far. literally too much. With the context of EIP 4337, there have been lots of effort which have been into this thing to make smart contracts more modular. Like the current wallet SDKs provider, all of them have their own different smart contract code format. So let's say if you are using Biconomics SDK, they have their own format. If you are using EtherSpose SDK, they have their own smart contract wallet standards. But bringing modularity will gonna help us to provide kind of like a uniform format for smart contracts for all the smart contract wallet provider, so that later on, if you want to have like, let's say, if you have a smart contract wallet which is following a particular uniform code, then later on you can enable a 2FA module over that. We could envision that there could be a module marketplace later on. There are EIP 6900. Following those standards, you can build your own modules. And the smart contracts, if they are following a uniform standard, they can subscribe to those modules. And then if you are making any transaction to a smart contract wallet, those modules can be a kind of like a pre-hook and post-hook mechanism to kind of work before and after transaction, before and after making transaction. And yeah, ownership delegation, we all know. We all must have worked with safe contracts, the multi-signatory authority, which gives us it kind of like a demonstration of ownership delegation. So yeah, we all know there's a lots of problems with EOA. Just to name a few, these are those. Like onboarding process is not straightforward. The most famous EOA which we are aware of is MetaMask. If you wanna start your Web3 journey with MetaMask, you might have known like what all terms you have to kind of like learn, what all concepts you'll have to first get over, and then you can start using the MetaMask. So onboarding is like, I don't know. Okay. And it always around takes 30 to 40 minutes for a non-native user to get over that particular steep learning curve, to learn about accounts, to learn about wallet, to learn about seed phrase, why I need to protect my seed phrase and all of that stuff. And the recovery mechanisms are also not that good. We are relying on a seed phrase. If the seed phrase is lost, we know what can happen. So yeah, EOS, I think, we're not gonna make it. That's why we have smart contract wallets as a first class citizen. So yeah, advantages with smart contract wallet, we already talked a little bit about this advantages in this the differentiation style, but let's get a little deeper into this. So yeah, we can implement our own custom programming logic. Like I said, in the validation, you can have your own validation. Like we were doing R1 validation in our Banana Smart Wallet. For modularity, we have multiple efforts going on. There are standards proposed by the Alchemy team, which is the EIP 6900. There are few organization and few proposed standards, which one of them is Rhinestone architecture. I will be sharing this slide and you can take a look over it. And with smart contracts wallet, specifically the 4337 compatible smart contracts wallet, we already have this added functionality of bundling transaction. We can make our transaction guestless by using the paymaster services. We can like hide a lot more of complexity by using the smart contract accounts. So yeah, let's we are talking a lot more about smart contract accounts, right? So let's just get a little deeper into 437 and how does a typical transaction journey looks like in 437. So what does 437 states? It's an account abstraction proposal which completely avoids the consensus layer protocol changes. Instead, it relies on the higher layer infrastructure. So why only 437? Like there are already lots of efforts being made in implementing account abstraction on the Ethereum layer. There are EIPs 86, EIP 2938, EIP 3074, EIP 86 talks on like you can implement your own custom signature verification logic and non-staking logic. By EIP 3074, it helps you, it basically says we're gonna have two more opcodes in the EVM, auth opcode and auth core opcode. With those particular opcodes, what you can do is you can just delegate the ownership of an EOA to a smart contract. So to bring the smart contracts account into the play. But all the previous EIPs kind of focus more on a protocol level changes. And there are already lots of efforts being made at being into the pipeline by the Ethereum Foundation. One of them is 4844, which are really more important than this EIP. So yeah, we definitely need some EIPs which kind of like use an higher level infrastructure and do not require the protocol changes to implement account abstraction. So we have 437. Yeah, so this is a typical journey. explained by Messari, a really well-known crypto research firm, of how a typical transaction in 437 ecosystem looks like. So first, the user operations get generated at the user end. Okay, and we also have the paymaster functionality. So once you generate a user op, in case if you want that particular transaction to get sponsored and want that particular transaction to do not consume gas from the user smart contract wallet, you need to get that user operation signed by a paymaster and need to append that paymaster data in the user operation. Once you got your user operation, you need to pass the user operation to the alternative mempool. Alternative mempool is a similar implementation to that of a canonical mempool where our normal transaction lies. And in the alternative mempools, bundlers monitors it and takes the user operations and bundles the user operation in their own local off-chain marketplaces. And once you got the bundler broadcast the bundler to the entry point contract, and at the entry point contract, basically it's validate the user op, and then it's also executes the user op and sends the relevant transaction to your smart contract wallet for execution, for verification and execution, to be honest. Yeah. And let's say if your user op contains the paymaster and data field, means you want to kind of like make that particular transaction gasless, then that particular check goes to the paymaster contract. We call the validate paymaster and data function to validate the signature of the paymaster who is trying to sponsor the gas for that particular user op. It gets validated, and finally the transactions gets executed. Once the transactions gets executed, the fees required for making that transaction happens, how much fees the bundler pays, all those fees get returned from the smart contract wallet to the bundler's beneficiary. So that was a little bit intro of how the typical transaction journey looks like. Yeah. So there was a guy called Zig Ziglar. He said like if the first steps are difficult, then how can you expect to travel the entire journey? So what Banana SDK are trying to do is kind of like for the first step is user onboarding, right? User need to go to the dApp, and for accessing particular dApp, he needs a wallet. And if the first step is in itself difficult, if the user needs MetaMask and need to get over that particular steep learning curve of like Web3 terms, then it's pretty difficult for him to get over and start using that particular dApp. So yeah, to solve that particular problem, we came up with Banana SDK. So yeah, so what is Banana SDK? So it's an account abstracted wallet infrastructure. To pinpoint, it's an SDK that makes Web3 easy to use. So what Banana offers is, we have several SDKs and fewer contracts. One of them is passkeys based wallet creation and signing SDK. It's the main SDK which enables dApp to kind of create smart contract wallets whose owners are the passkeys of user. I will demonstrate how you can integrate and how does it actually look like. We also have a smart contract wallet SDK with MetaMask as an owner. There are few clients whose users are actually region users and they want their owner to be MetaMask wallet only. So we had created an SDK for that as well. We have our own passkey manager modules. So let's say if you are a wallet or wallet infrastructure and are looking for a passkey based owner, what you want is you already have your smart contract wallet code, and you want to enable the transaction authentication and signing using passkeys. You can use our passkey manager module SDK. And we are also working on Web2 friendly recovery mechanism to in case user kind of in situation where its wallets can get compromised. Yeah, so let's discuss a little on how we kind of achieve the passkey based mechanism. How does passkey signs the transaction and how the transactions get verified. So there were few steps we did to enable passkeys based signing. First is validating SEC256 in R1 SIEM signature, because the signature which gets returned once the passkey signs a particular data is not K1 based signature, which is used in the Ethereum network. It's R1 based signature. And we are using passkey manager module for kind of handling the user's passkey, so that on chain we are using the correct public key corresponding to the private key to check the transaction authority. We are using WebAuthn interface. WebAuthn interface allows us to create and request a signature from a passkey. And we have overridden the 437 signer class which comes with EIB 437 implementation, and built our own class override after implement. No, we are not overridden exactly. We had extended the 437 signer class and built our own banana signer. And yeah, finally the key management, like corresponding to the corresponding to the pass keys. We also have a kind of like a mapping between pass keys and key ID. Those key IDs help us to identify which particular pass keys we're gonna use. So we are also managing the key IDs basically. So yeah, validating the R1 based signature. So there's a templated method called validate signature in the 437 smart contract account implementation. We had overridden that, and we are currently using the SecP 256 R1 solidity verifier to verify the R1 based signature. And yeah, like the implementation for solidity verifier which we are using, it's an open source. Let's continue. Passkey manager modules, as I said, it helps us to kind of like stores the mapping of key ID corresponding to passkeys. A user can have multiple passkeys in his device, and we need to pinpoint which particular pass from which particular passkey we need the authentication from. So this passkey manager module helps us to stores that. And yeah, so we are using WebAuthn interface. The WebAuthn interface have like certain APIs enabled in it. The DOM Navigator API help us to kind of create a request to generate passkeys in user device, and it also helps us to get the signature from the passkeys. So we'll have to kind of like generate a public key object, public key credentials object, pass it to the create API or get API, and it returns the signature or public keys. So yeah, this it's a typical interaction. Let's see how does it look like if a DApp integrates our SDK. So here's the timeline for a DApp, and in the second, at the second it's for SDK, third is for WebAuthn interface, and fourth is for device hardware. So let's say if from the DApp we got the request for creating a wallet, the SDK receives that particular request, and the SDK requests WebAuthn interface to generate the key pair, and that request goes to the device hardware. The create request gets successful, and the public key corresponding to the private key which has been created inside the device of the users gets returned into the pair creation response. And once we get that particular response, we pass the response and generate a Ethereum compatible address. And once we got that Ethereum compatible address, we initialize an instance and return that instance to the DApp. Similarly, if the DApp requests for transaction creation, we basically forward the SDK basically generates the user of hash. User of hash, the ultimate entity which gets signed and verified at the smart contract wallet end. That user of hash gets into the device hardware. The device hardware signs that particular user of hash corresponding to the with the passkeys and return the signature response. And we pass that particular signature response, extract out the signature from it, and then the transactions get broadcasted to the entry point. So that's was the typical integration. Maybe let's have a short demo on how you can integrate Banana SDK. You just have to kind of like use few lines. You just have to instantiate Banana object, and then once you got the object, you just need to call the create wallet method of that object. And if you want signer for the wallet, you just need to you can just call get signer method on the wallet instance to get the signer. And once you got the signer, what you need to do, all of us know, like you just need to create transaction and send transaction. So let's just see how it would look like when we integrate, and also have a demo of like how we can actually sign the transaction using passkeys. So basically, like as I previously showed you, there are only 3 to 4 steps which you need to remember to start using Banana SDK. So first, you need to create the instance of Banana class. We are calling it Banana instance right now. And in case if you want the transaction to be sponsored, then you can also pass the paymaster option. In the paymaster option, you just need to pass the paymaster URL, which will gonna sign the transaction and the corresponding chain ID for which the paymaster aim for. And to create a wallet, you just need to call the create wallet method of Banana SDK instant. It will help you to create wallet. And let's say if user already have a wallet, then you can just get the wallet name from the wallet get wallet name method of banana SDK instance. It will return the wallet name, and you need to now you will have to kind of like utilize the connect wallet method and pass on the unique wallet name, and the wallet corresponding to that particular wallet name will get returned, and you then use the wallet to extract signer and then use that signer to broadcast transaction. So like enough talking, let's try to make one transaction. Let's try to make a wallet first and then do a transaction. So yeah, like let me just start the server. Oh, it's just starting in a few seconds. Yeah. So this is a sample demo application which I just created to demonstrate the wallet creation, connecting wallet, and making transaction. So if the, I landed in this particular dApp for the first time, so I don't have any wallet yet. So I can just click on create wallet. Once I click on create wallet, I just have to provide a unique username for my wallet, and later on with this particular username, I can access my wallet if later on if I need. So let's just provide a username Web3Conf demo wallet and click enter. So now with this particular username, what we are actually doing is we had requested for a passkey creation at the devices end, and the passkeys had been created now. Now it's asking for create passkey for this particular URL, and yeah, we hit continue, and now it's asking for the authentication. Once we give it the biometric authentication, then it will start creating the public private key, the passkey pair into the device. Yeah. So it's created the wallet, and now it will close it, and yeah, it's still loading. The wallet will gonna pop up in just a few seconds. Yeah. So now we have this wallet address available with us. You can just check, like currently we don't have any contract available with this particular address. Once we gonna make our first transaction, in that transaction only we'll gonna batch the wallet creation transaction as well. So yeah, like the wallet has been already created, and it's a typical wallet instance, right? So you can just get the chain ID, the network information, and you can sign the message, make transaction, bundle transaction. So all the complexities are being kind of like wrapped into the wallet instance only. So let's just make a transaction using the newly created wallet we had. So let's just fund this wallet before, because the transaction which will gonna made would involve a transfer of few tokens. So it's better if we already have this wallet pre-funded. Let's just wait for a few minutes for the transaction to get successful. We're still sending the transaction. Let's see. Yeah, so we had already funded our wallet with 0.1 matic, and let's do a transaction for staking some tokens. So let's make a transaction. So when I clicked on making transaction, what internally happening is the transaction object has been passed to the signer, and this is banana signer, and that particular banana signer takes the transaction and fills that particular transaction with the relevant fields. And once we got the actual populated transaction, we generates the user up out of that transaction, and yeah, so now I'm at this interface. So if I'm at this interface, means the user operation has been already generated, and now I'm gonna give the access to the SDK to sign the particular user operation hash corresponding to the user operation which is generated right now. So I click on confirm, I give the access to the, and now I need to sign that particular user operation hash which will gonna verify at the smart contract wallet end. And once I give my biometric, it signs that particular user operations hash and broadcasts it. Sometimes it's asked for multiple authentication, because like sometimes the RNS values returned for that particular signature might not be equal. So we are just reiterating the process. So yeah, the transaction has happened, and these are the transactions logs. So let's maybe just go to the smart contract wallet which we have just created and see how the transaction look like. So this was the smart contract wallet which we had just created, and yeah. So previously it had zero point 0.1 matic as a balance, and now it has somewhat zero point 0.4 times 9 matics. Yeah. So as we can see, the with the first transaction itself, the transactions happen for sending this much amount of matic from the smart contract wallet address to the destination address, and we got the contract deployed with the first transaction itself. And yeah, and we basically signed the transaction using our device passkey. We didn't have to rely on MetaMask to create a public private key pair first and assign that key pair as an owner to the smart contract wallet. We just use our device, and with the help of passkey we signed the transaction. So that's what about the banana SDK integration. Yeah, so like as Linus Torvalds told, talk is cheap, show me the code. So we showed you the code. Okay. So yeah, the demo is already done. So what's next? Like, what's the bananas roadmap? We had already like doing pretty much in solving the onboarding issues. But what after onboarding? Like, even if you onboard a user to your dApp, you want user to use your dApp, right? You don't want him to like, yeah, he just creates a wallet and then he finds out that particular dApp too much complex to use and just leaves that particular dApp. So intents maybe. So like intents are just like an abstraction layer over the transactions. So with intents, we kind of like aim to capture what the final desired outcome user want out of the user wants basically. So let's say I can have an intent that I have 5 matic tokens and I need some USDC tokens against those matic tokens. So for this particular intent, let's say if we see this particular intent with the transaction perspective, so what I will have to do is I would have to go to multiple swap exchanges, then find out which one is giving me the best number of USDC tokens against those 5 matic tokens and make a swap over there. But with intents, what we are envisioning is user should be able to just kind of like express his desired outcome. What he actually wants. He just wants maximum USDC token against the 5 matic tokens, and rest of the complexity we need to avoid. So like we are exploring quite a bit in this particular intent space, and like while at our exploration, we built a sort of a POC at the Global Paris Hackathon. I just wanted to kind of like demo that POC over here, and we are currently looking for peoples and clients who actually want this particular intent infrastructure and their protocol to be used. So it will help you to kind of like get a sense of where could intent get fit into your protocols, and if it sounds synergical, we can connect. So yeah, so this was the demo which we had presented in the Global Paris Hackathon. If you might not have seen it, then I'm just kind of reiterating here. So the first intent which will the firstly what we have did is we just selected the corresponding network. Like on Polygon network, we want to do our we want to kind of like interact with the Polygon network. We want to interact, and we just connected our own Banana SDK wallet. So let's just go, and our wallet is currently connecting. The wallet is connected, and what our intent is like, can you please help me to get maximum USD token against, let's say, 0.1 matic token. So this was the user's desired outcome, to get the maximum tokens against 0.1 matic token. So if intents were not there, he just had to go to multiple swap exchanges, find out which particular swap has the best liquidity with the lowest slippage he can make swap for. So, but we wanna hide all those complexities. So what we did is, so yeah, so user just came and expressed his intent in a physical manner, and yeah, so at the backend, what's happening is there's a solver which basically taking at intents, finding the best route for making that particular intent happen. Once it gets the best route, it's building the transactions, And once the transactions gets built, the transactions return to our smart contract wallet SDK. During the hackathon itself, we built our cross-chain transaction bundling SDK, which kind of like take these sets of transactions, bundle so transaction chain wise, and once the transactions get bundled chain wise, it gets the signature over those particular transactions from the users, and with the help of free layers, assign those transactions to get executed serially. So yeah, so here the solver proposes a route of that it will gonna swap the 0.1 Matic token against USDC token, which was our intended intent. So yeah, like once user can confirm that he actually wants to swap this amount of Matic token against USDC token, he just clicks on OK, and it will prompt the users to kind of like sign the transaction. Now, yeah, so again, we are using Banana SDK in-house, our in-house infrastructure in this intent chat-based UI. So we signed the transaction, and yeah, the transaction happened. So like in this particular transaction, so you can see like we at the backend at the solver, and what we actually did is we integrated an aggregator, the 1-inch aggregator, which helps us to find the best route for executing that particular swap intent. So this was one of the intent, but apart from swap, intent could be a little much complex. So let's say you could have an intent of, let's say you want to stake some Matic tokens for best liquidity, for what I'm saying liquidity is for best yield. So it might not be the case that the protocol which is giving you best yield can available in Polygon network, which you are currently interacting with. It can be on Avalanche, it can be on Optimism. So the solver currently here figures out what could be the best staking platform or the protocol available for getting the best yields. Yeah, and once it finds out what could be the best route for user to get the best yield for the amount of Matic he wanna stake, he just proposes that particular route to the user, that this transaction will first bridge this much amount of WMatic token, as the token needs to get bridged. So WMatic token will gonna involve a wrapped Matic to Avalanche blockchain, because the staking contract on the Avalanche blockchain are giving the best yield. So we got this particular inference from the solver, and once we get this get the inference from the solver, along with inference we also have the sets of transactions. Those sets of transactions get received at the smart contract wallet SDK ends, get bundled according to the chain wise, and once they are bundled, they get signed. So currently, okay, I think I should. Yeah, so when I clicked on OK, it will enable me to sign the transactions. So yeah, maybe maybe like I think the signing process had been skipped. So yeah, like for making this transaction happen, the first thing which has happened is the swapping of Matic token to WMatic token, and then the corresponding WMatic token have been bridged to the Avalanche blockchain by the relayer, and then the corresponding 0.002 WMatic token have been staked to this staking platform which is available on Avalanche blockchain. So yeah, so in this manner, we kind of like enabled user to achieve his desired outcome by hiding the complexity of transaction creation. So yeah, like we are still exploring. We are really early in this space, and any projects which is actively working in this intent space is still deciding on what could be the best way to capture user intents. What they are all coming with their own constraint based ESL to capture user intent. But yeah, we are open to kind of have a discussion with clients, and like we are kind of like exploring this space to come up with the best standard to kind of like capture the user intents. Yeah, so that's enough. Yeah, that's all for my talk, and we can connect over this platform. Unfortunately, I don't have a single username all over the platform. You can take any one of them if you want to connect. So yeah, thanks.
So very insightful and deep session by Nitanshu. So does anyone have any questions? Yes, sure. Soham.
Yeah, really awesome talk. I just had a question. I mean, EOA, we can just put in any wallet, right? MetaMask private key I can export and put in any wallet like Trust Wallet, Rainbow Wallet. But similarly, is there something which is movement that is going on for smart wallets Because if some smart wallet is there, I can only use their app. But I want to use a different app. So right now we cannot do that, right? But is there any movement going towards that?
Yeah, actually, like even if you are using the smart contract wallet deployed via Banana SDK, those wallets are interoperable. Let's say if DApp A and DApp B are using the Banana SDK, you can use the wallet created in DApp A to the DApp B itself.
Okay.
That's kind of interoperability we have.
Yeah, that's awesome.
Yeah, thanks.
Anyone else?
Anyone else? Sure. Please.
Yeah, hey. So for the intent thing that you showed, once your solver creates the transactions out of the intent, how do you kind of make sure the sequentiality of the transaction? Is it through a private order flow, or like, let's say someone's providing the best liquidity to you, how do you make sure the sequences are maintained within a block?
So the thing is like we modified our smart contract wallet a bit. So we have like the corresponding cross-chain calls in our smart contracts. So so like once we get the bunch of transactions, let's say the transaction flow will involve chain A and chain B. So once the executions on chain A happens, from the smart contract wallet end, we are emitting a function that this particular transactions has happened, and once that particular when that particular event has been emitted, we are listing that particular event from our relayers. Our relayers listen that particular event has happened on chain A, and then they kind of like broadcast the user operation, which is already been signed from the user to that particular destination chain, the chain B.
Okay, makes sense. Yeah, thanks.
Yeah.
Anyone else in the house with a question? Okay, no, that was all I think. So thanks a lot, Nitanshu, for your time, and see you.